this video. In this video, we are going to discuss one more LLD problem that was recently asked in Microsoft, multi-API combined rate limiter. If you are going to get this LLD problem, you should be aware about what is rate limiter, what are the different rate limiting algorithms, and what is the need of rate limiter. If you are not aware about rate limiter and its usage, then you might not able to solve this problem if you are asked this problem in an interview. So I will also give you an overview about rate limiter before deep diving on the solution. So let's try to understand the problem statement first, then we will see. So what we need to design? We need to design a rate limiting library that supports the following advanced requirement. Support different rate limits for different API endpoints. Let's say in our service or application, we have different endpoints like login endpoint, search endpoints. So what we need to provide? We need to provide different rate limits for different kinds of endpoints. That means what is rate limit? First, let's try to understand. So let's say I am a user 1. I am Naman, right? If I am trying to log in an application, I should be only able to hit login API 5 times in a minute. That is what this means. Login has 5 requests per minute. Let's say if I am trying to hit with wrong username, wrong password, then I should not able to hit it, right? So if I try to hit it 6 times, I should not able to hit it and I should get a different kind of error, 429, too many requests. And once the user is able to log in, then he can use the search endpoint with a different rate limit, right? That is 100 requests per minute. That is called granular limits. Now again, we need to have some more constraints. Multi-period constraint supports multiple time window for same API. For example, 10 requests per minute and 500 requests per day. So if you see above, search can have 100 requests per minute, right? So here, if we say 100 requests per minute and 5000 requests per day for search API, this condition also should be supported by our rate limiting library. And then we will also provide ability to have combined or aggregate limits. Support rate limits that apply to a group of API combines, that is total request to upload or download. So see, whenever we are uploading or downloading from our system, we are hitting the server, right? So the total limit to upload and download should not exceed 50 per hour. That can be a aggregate limit, right? The system should be thread safe and provide low latency decisions. So this is what we need to design in this multi API and combined rate limiter. So before going into these details, like how we are going to come up with granular limits, multi-period constraint or aggregate limits, we need to understand how to design a basic rate limiter. That what is basic rate limiter? Like if we have this endpoint, or I am a user 1, and there can be user 2. So for each user, this limit should apply. User 1 also get 5 requests per minute and user 2 also get 5 requests per minute. That is the basic behavior of a rate limiter. Okay. So let's understand how we can provide this ability. So let's take a time constraint of 1 hour for simplicity. Okay. This is the time window. So this is 1, this is 2. So if we see, login API has 5 requests per minute. Let's say it has 5 requests per hour for simplicity. So between 1 to 2 hours, if user means user ID. So if a user ID is user 1 tries to hit it 1 time 2, 3, 4, 5. This should be allowed. We should be, so we are going to have login API. User should able to log in if he tries to log in 5 times within an hour, right? But if he or she tries to log in 6 times, he should get denied. This should not be accepted. So for this, if we try to understand, this is a time window, right? Between 1 to 2 hour, or 1 to 2 minute, or 1 to 2 second, right? So in that time, we can easily maintain a counter that can start from 0 to a max limit, correct? If the counter is greater than max limit, we need to return false. Let's say for rate limiter, we will define an interface rate limiter. We will have allow, and we will have client ID. And here we will return boolean. Let me just erase it. Let me write it properly. We need two things. One is timestamp and one is client ID. So allow method will have client ID and it will return boolean. And when we will implement this method, right, inside rate limiter, we will be checking these counter values and max limit, right? So this is a basic example of how we are going to implement rate limiter. And this technique, what I have just explained, is called fixed window. Because here we have fixed timestamp where we will be using for comparing if this count, if these values request that we are hitting lies within this window, then we will be checking these two values, max limit and counter value, and incrementing it. Once this window get over, we will have another window. We will have another window from 2 to 3, right? And here we will reset the counter to 0. Let's say if counter has increased to 5, we will reset it to 0 again, and again it will start looking. So this is what we need to implement with this login, search endpoints, and for multi-period constraints also. Now this fixed window rate limiter has one issue. Let's say this is the window 1, 2, and this is the third. So here we have two windows. First window and this is second window. Here if a user tries to hit at, this is 130 and this is 2.30. Let's say if I am a user and I am trying to hit 5 times in this period, 1, 2, 3, 4, 5, and there are 0 hits in this period, right? So it should allow. And now the counter becomes 0 at this point, at this junction, right? And if I try to hit again 5 times, 1, 2, 3, 4, 5, I would able to hit it, right? So if you see from period of 1.30 to 2.30, we are able to hit 5 plus 5, 10. That is, what is our max window size? Window is 5, but we are able to hit 10 times in when there are at the junction of two windows. So this is the problem with fixed window. Although it is easy to implement and easy to use, but this has this problem that it allows 2x request near the junction. Okay, so how we can solve this? For that we have one more algorithm, that is sliding window. So here our window will slide with the timestamps. So it will see the last timestamp, and whenever time moves, that window will also move along with it. So if we try to hit during this time, it will see this time. Okay. But if we try to hit here, let's say at 2:15, then our window will become something like this, and it will check. So if you see 1, 2, 3, 4, 5, 6, 7. So these two requests will get rejected in sliding window technique. Here we need to store the request in the form of we need to store the time in the form of timestamp, that is sliding window log technique, and then there is one more sliding window counter. So that we will see in our implementation part. Then after this we will have some more algorithms. That let's see, we have leaky bucket algorithm. So what will happen in this? These are different algorithms. Two I have already explained: sliding window and fixed window. And then we have leaky bucket algorithm. Here what will happen? We will have one time frame. Inside that, let's say in 1 hour, we will have bucket. This is our bucket is filled at a constant rate. So what does this mean? And discard records if the bucket is full. So if you see, let's say whenever a request comes, it will starts to fill. It will have a capacity. Let's say it will have a capacity of 10. Okay, this bucket can have 10. We can fill it 10 drops inside it. 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? And here we have at so here he will have a request rate. Okay, refill rate. Here we will have a discard rate. So if we let's say this is for 1 hour, right, or 10 second. For 10 second it can hold 10 10 drops inside it. For each second, one drop will go outside. Okay. Now it will have 9. Correct. If one will go out, if you see, now it has 9. So now the capacity is going to be, there is going to this bucket can accommodate one more drop. Correct. So this is how this algorithm will work. Leaky bucket. So it will leak the droplets, and bucket is going to get filled. So when we are filling, so how many requests we can hit? The request that we can hit is these number of droplet that this bucket can hold, and at after a certain period of time, this will discard request if this bucket is full. And what it will do, it will try to remove the droplets at a certain period of time. So for 10 seconds, if it has a rate of holding 10, then for each second it will be removing. So let's say after 5 seconds, our total 5 droplets will get removed if there are no incoming requests. So we will have a capacity of 10 minus 5. Okay. Similarly, we will have one more algorithm that is token bucket algorithm. So here, what token bucket algorithm, what happens is we have a bucket which has already a number of tokens inside it initially. So let's say for first 10 seconds, it has 10 tokens. Okay. And whenever there is an incoming request, one incoming request will take up one token. Okay. One token it will take. So let's say at T0, one request hit. Initially, there are tokens 10. After one request hit at T equal to 0, token will become 9, right? Let's say if we hit another request at T0 and inside this bucket there is a token refill rate as well. So there can be, we can say refill rate can be 1 token per second. So at T equal to 1, and then there can be maximum token limit. So this bucket can hold 10 tokens. Okay. Here it is written as capacity 5, but for simplicity we are assuming it will have 10 tokens. So at T0 there is one requested token is 10. So at T equal to 1, our token there is refill rate. This is the refill rate. Okay. 1 token per second. So at T equal to 1, token will again become 10. Correct? Now if any request again comes, let's say we are hitting multiple requests. So at T equal to 1, I hit 5 requests. So each request will take 1 token. So token will become 5. Okay, at T is equals to 1. Now at T is equals to 2, because of this refill rate, token will become 6. Okay, now it will not become 10. So at T is equals to 2, if we hit 10 request, what will happen? We will this token bucket algorithm will give 1 token per request. So only 6 requests can be passed and 4 will be discarded. Okay, that's why we use this token bucket algorithm. So what is the main advantage of this? At any point of time, it cannot go the maximum capacity, and we cannot hit any request which is greater than the capacity of the bucket and in a particular interval of time. And we can and we need to wait. Let's say in 10 seconds we will have 10 token. Let's say at T is equals to 0, we hit 10 request. Then till T equal to 10, we will not again able to hit 10 request at each second. Okay, we need to wait to refill, to the tokens to be refilled. So at T equal to 1, we will only able to hit one request. If we try to hit more than one request, then those will get discarded. This is what about token bucket algorithm. Now let's move to the problem statement. Now what we need to do is we need to have different rate limits for different API. That means login can have and search can have 100 requests per minute. That means these period limits we need to set, and then that whenever a request is going to hit on an endpoint, these are kind of configuration, right? So we need our rate limiter, whether we are using token bucket need to check this config, and then based on whether this config allows us to pass this request or not, we will be returning the response if it is allowed or not. So our rate limiting library will be first checking if it is under the certain limit, or for multi-period constraint also we will have different configs. Let's say for aggregation limit, right? This is what we need to design as part of this LLD problem. So by looking at this, we will have a rate limiting interface. So all the libraries that we discussed, sliding window, fixed window, token bucket, leaky bucket, that will be getting implemented under that interface. Okay, and apart from that, then we will need to use to fetch like which algorithm we need. So we will have one configuration, login has 5 requests per minute, search has 100 requests, and same API can have multiple requests. So along with this config, when we are setting this config, we will be setting algorithm as well, right? So as part of this design, we need to make sure that two things we should configure: the endpoint limits and their constraints, aggregation limits. There can be more than one limits, and there can be more than one algorithms. So now let's move to the how we are going to solve this entities part. So we will have something like this. We will have one class period limit. That is very important. What we will have as its fields, we will have the window size. So here if you see in this question, we are looking for 5 requests per minute, then we have request per day, then we have request per hour, right? So as in the period limit class, we will have max request and the window size, right? And as we have seen in question, there it can have per hour, per day, and per minute. This we can create as a method for this, so that we can set number of request, number of max request in 1 hour, in 1 day, in 1 minute, right? So we can have these methods: per minute and max request, per hour and per day. Okay, that is going to be our first method, period limit. Then we need to have some kind of rules, right? For each endpoint we need to have endpoint rule. Let's say how many limit it is going to have. It can have more than one. That is the requirement of this problem statement. It can have more than one limit. So we will be using list of period limit for endpoint rule. So in endpoint rule we will have field endpoint name, let's say like search, login, upload. So we will have periods. This is going to be list of period limit. Okay, and then as we have already discussed, the algorithm type. Inside endpoint rule we will set, okay, for search endpoint, as it require exact data, there can be many requests, right? More than 100 requests per minute, or it can be 1000. So if we used fixed window for this, then it can have problems, because it will allow 2x burst, right? 2000. So if the rate is more for lesser period of time, this algorithm can create issues for us. So what we will do is, for endpoints which are like where we will have more requests per minute or per hour, there we will use more concrete algorithm. So we will go with token bucket. So that we will define at the time of defining the endpoint rule. And also, like, let's say if we want to change it, we have a field getters and setter method to change the algorithm type, periods, or if we can add new period. Let's say tomorrow some other requirement came and we need to add one more period limit per hour, per day, and per minute, right? Even we can add per month. That also we can check. So these things will come inside this endpoint rule class. Then we need to have aggregation rules, right? For that we will have similar kind of thing, but that class will have more than one endpoint, correct? So for that we will have aggregate rule. So here it will have a unique group ID and it will have a set of endpoints. Okay, again those can have multiple period limits, and again that can have different algorithm types. So these two I think are as per the what we are going to solve in this problem statement, right? Then here we will have getters and setters, and then we will have algorithm type. As I have shown different algorithms that we are going to use as part of this problem: token bucket, sliding window, leaky bucket, and fixed window. Okay. Then the main interface, rate limit bucket. So it will have one method, would allow and consume. So what would allow would do, like why we have created two methods, right? See, this will tell us if whatever rules, endpoint and aggregation rules that we have created, right? Those are met or not, this method will tell, correct? And bucket factory we will use for creating the different algorithms, different implementation of these algorithms, and consume will consume it. So now what we are doing in consuming, let's say we have 5 requests per minute, right? So when we call the consume method, it will increase the counter or it will reduce the number of tokens. So this is going to be used in case of window, fixed window, and this is going to be used in case of token bucket algorithm, correct? These things we will be using. So then we will have a facade class for handling our rate limiting library. So here it will have a hash map of endpoint rules, aggregator rules, right? Bucket factory for creating the different algorithms and its implementation. Then here we will have endpoint buckets. For each endpoint, there can be different rate limiting bucket, like there can be different algorithm we are going to be using. It can be used inside aggregator rules and endpoint rules, correct? That we will see when we will look at the implementation part. Group buckets for aggregation rules and logs. So here we will also have a map of logs. So for each, let's say user 1 tries to hit right, so we will be using a separate log for user 1, and user 2 will have separate logs, so that our system can be scalable. Here we will have methods like add endpoint rule. This will allow our library to add different endpoint rules, aggregator rules, allow request. This will have client ID and endpoint, and this internally, this allow request will be calling the endpoint rules and aggregator rules to check if it is allowed or not. And this collect bucket method We have created separately to actually collect like from these two buckets, endpoint buckets and group buckets, and then we will be performing our consume operation inside our rate limiter. So then here we are solving token bucket and other bucket implementation part. Now let's move to the UML diagram. So here you can see the whole diagram. So here we have our facade class. Let's start from here, rate limiting bucket. So here it will have would allow and consume method, and all will be implementing it. Token bucket, sliding window bucket, leaky bucket, fixed window bucket. So if you see, it will have max request, and every every algorithm has max request field. Then leaky bucket, fixed window bucket, and sliding window bucket will have window millisecond, because these two are kind of similar, and sliding window is better, so it will handle one more field with a list of DQ of timestamps. What it will do is we will be uh, inside a particular time slot, we will be putting the timestamp and removing the timestamp from behind. That is what we are going to do. In leaky bucket, we will have a drain rate per millisecond, current level, and last updated millisecond. In token bucket, we will have refill rate per millisecond and tokens and last refill milliseconds. So all these algorithms how we are implementing in the millisecond. If you see window millisecond, max request. So this interface these are implemented, and this bucket factory we will be using for creating each of these algorithms. Then we have these two rules, endpoint rules and aggregation rules. So here we have these field endpoint, period, list of period, and algorithm type. Here we have group ID, endpoints and periods, list set of endpoints and periods. As endpoints can be should be different, so that's why we have taken set. Here it is using again algorithm type and period limits. Period limits has max request and window time. And then this combined rate limiter is actually using the endpoint rules, aggregation rules, map, bucket factory, endpoint buckets, and group buckets. And this logs we are going to use inside this allow request method. So now we have seen the UML and the problem statement methods. Now let's move to the implementation part. So now let's try to go inside the combined rate limiter. So what we need to do here is in combined rate limiter we are using endpoint rules, aggregation rules. Here we are using concurrent hash map, bucket factory, endpoint buckets, group buckets, and logs, right? Let's first see this interface. So it will have would allow method with boolean return type. After this, let's see period limit. So here it will have max requests and window in millisecond. So here we have constructor where we are checking the values. If it is less than 0, then it should be illegal. And then we have created some methods per minute, per hour, and per day, where we are checking the max request. And here as this period limit and this whole rate limiter is using time in millisecond, so we are setting the along with max request we are setting the time in the new period limit as millisecond as 60 seconds, so 60,000. For 1 hour we are setting this, and for whole day we are setting this value. So this will help us when we are going to create period limits. Now we will have endpoint rule. So here we have endpoint, period, algorithm type, and just the getter methods. And after that we will have aggregate rule. So here we will have a group ID. Whenever we are going to create a aggregate rule, we will have group ID, endpoints. So here we are going to have set of endpoints like upload and download, and these two fields are similar to endpoint rule. Bucket factory is very simple. We are just creating based on the period limit our different algorithms. Now let's try to see the fixed window bucket. So here fixed window bucket is implementing the rate limit bucket, which has two methods, would allow and consume. So here we have max request window millisecond and counter that we have gone through, like we will have a counter with zero value initially. So when we are initializing it in constructor get max request, we will get from period limit, and same for window size, we will also get from period window size, right? Then we will have window start millisecond. When is our window going to start? So this is the whenever we are initializing this, at that point of time we will start. Then in would allow we will check if we have window, if needed we will pass the time. We will have a variable elapsed which will compare the now with the start. So whenever we have initialized this value is set, right? If it is greater than the window size, then we need to set it to current time. This is what we are doing, and at the point of time when we are resetting the window, we are going to make the counter value as 0. This is what we are doing, and we are checking if count is less than max request, then we will return true. Then we will have consume method. Here again we will check the same logic, and here we are incrementing the counter until it reaches the max request. Okay, this is what we are doing. This is easy to understand. Then let's see the token bucket algorithm. Here we have max request that is coming again from period. Here we will have refill rate per second. That how we will calculate. Here we will get max request time and the period window size. So this is how we will calculate the refill rate. This is the total time, max request, let's say 10 second, uh, and max request can be 10 and window size can be 10. So it will become 1, right? 10 divided by 10, 1 per millisecond. Let's say in 10 millisecond, we have size 10 millisecond. So per millisecond, it will be our refill rate will be 1 token. So initially, what is the token amount we will have? That is going to be max request. And last refill rate, that will again define current millisecond. So here again we are checking. We will be allowing if the token size is greater than 1, and we will be checking this refill logic. So here we will be calculating these values. We will try to find the delta, then we will check the added with how we will calculate this added values, delta and refill rate per second. Then we will have minimum of max request or token plus added, whatever tokens we have and whatever we are going to add at a particular time. Whatever is minimum, that we will assign to tokens, and then last refill millisecond will become the now millisecond. For rest of the algorithms, you can go through the code. Now let's try to understand the combined rate limiter part. So here we have a simple method to add endpoint rule. Add endpoint rule, where we will have we are putting the endpoints, and in the aggregate rule where we will be adding the aggregates. Here we will have allow request method. This is going to be most important method. So what we are doing, we are collecting buckets, where we will pass collect buckets endpoint. In this method, what we are doing is buckets method. What we are going to do, we will create a rate limit bucket result array list. Okay. So here we need to check two things. One is endpoint rules hash map, and second is aggregate rules hash map. So in the let's say this endpoint, if it is search, right? So we need to check if it is present in endpoint rules. If it is not present in endpoint rules, then we should not go in this condition. Then we will only be checking the aggregate rules. if it is present, let's say search endpoint is present here, right? Then we will check the endpoint rule period limits. So it can be more like 5 requests per minute or 100 requests per hour. So we will have for loop for that. Then we will try to create a key for this result list, right? Which we are creating like endpoint rule, endpoint, and the maximum window size and client ID. So here client ID will be a unique identifier in key in these maps. So here what we'll do, there is an endpoint bucket that we have here in the in our combined rate limiter facade class. In this rate limiter, we will be adding the our rate limiting algorithm along with its ID. So here it will have a unique ID which has client ID, right? So if we see here, this is what key. So in endpoint bucket, we will be setting it compute absent. If we have already set it, then it will just fetch that key, this key. If it is not present, then it will try to create a bucket factory at first point in this array list, the bucket factory with the period and endpoint algorithm. So this will give us a bucket, rate limiting bucket like sliding window or token bucket algorithm, and this will have the key. So that we will be adding inside the uh, key of this particular value, we will be adding inside the result. Okay, because this will give us the bucket, the algorithm that we are going to use for this particular endpoint and for particular client ID. So here it will have one value. Let's say if there are two periods, there can be two values here. For aggregate rule, we will fetch all the values and we will check if this endpoint is present in this aggregate rule or not. Again, if it is present, then we will again do the same thing what we have did above. We will create a key using the group and the client ID. So this key is going to be different than this key. So again we will perform the same process in the group bucket. So now this value can have let's say if it holds true here and it holds true here, then it can have two or three values, right? This value we will be returning it back. Here we will get the buckets, how many rate limiting buckets we have. Let's say if endpoint is not registered any bucket, then we should be returning true. We should not be holding back our, we should not be denying the request. That is why I have put this check. Now we need to use locks, right? So we will create client ID and endpoint lock, and again we will put in this map, and we will create new map if it is not present, new lock if it is not present. Now we will start the buckets that we got, or the rate limit algorithm that we got here, right? From this, from the aggregation rules and from the uh, endpoint rules. It can be more than one. Here we will check, go through in each of the bucket. Let's say if one allows, right, then it will return, it will do nothing here, correct? But let's say if second limit is getting crossed, per minute request, let's say 5 per minute, right? This is true, but 100 per or 50 per hour is false, correct? Then this condition will return false and our request will get discarded from this log, from this allow request, right? So there can be two buckets or two algorithms, but one is enough to return to discard it. Let's say if both of them holds true, then what will happen? Then we need to call the consume method. So what consume method will do, if we see, it will increase the counter in fixed window, right? That is very important because for next count our count should not should be incremented. Otherwise, let's say if there are more than 5 requests and if we do not increment the counter, then it will allow, then there is no point of checking these things. So it will not only if there are more than 2 or 3 buckets, right? If it is present in token bucket, also let's say one is fixed window, second is token bucket, then it should decrease the token, right? And we should refill the token as well at that particular point of time, right? So that's why what this method is doing, it is going through all the buckets or all the rate limiting algorithms and incrementing the values, decrementing the counter, because this is allowed, right? Next time it will come, let's say if it is allowed, and again it will come, it will again increment the counter, right? Then what will happen here? The third time in would allow method, it will check this thing also, right? Count is should be less than max request. If it comes equals, right, it will get rejected. So that is the point of doing these two things, right? This is what we are doing in allow request. Now let's see the demo part of it. So here what we are doing is we are creating our combined rate limiter uh, object. Then we are adding the endpoint rules. So let's say for login we are adding as in a list period per minute, right? Max request allowed per minute is 5. And algorithm type we are adding token bucket. Okay, this is for login. Then multi period such as 100 and 500 per day. So here if you see, that's why we have provided in the endpoint rule list, we can add multiple period limits per minute, 100 requests per minute and 500 requests per day. Here we have set different algorithm, sliding window algorithm. For aggregation limit we will have different method, add aggregator rule. Here it will have a new group ID, let's say storage IO, and then we have set up upload download. Whenever the endpoint is upload download, it needs to go through this aggregation rule. And then here we are setting per hour limit and algorithm type sliding window. I think sliding window is not correct here, so we can change it to token bucket or leaky bucket, right? Here we are client ID, then we are trying to simulate it in a loop. Now let's try to run it. So here if you see, for login 5 per minute, right? So login 1 to 5 are allowed, then after that it got denied as we are running in a loop, so it will go within some milliseconds. There is no point of you know hour limit to get reached out. For multi-period search, 100 per minute, 500 per day. First 105 request, 100 allowed, accept 100. So 5 requests will get rejected. For aggregate, 30 uploads, 30 allowed. 30 downloads after uploads, right? We tried 30 downloads after upload. So only 21 got allowed. Total storage 51, which is expected 50. Total alloweds are should be 20. So what algorithm we are using here? For leaky bucket, right? So we need to see how it has allowed 51 requests. Let's try to change the algorithm here. Instead of leaky bucket, let's use token bucket. Now try to run the. See, a token bucket is giving us correct results. 30 uploads, 30 allowed. 30 downloads, 20 allowed. Total storage input output is 50. That means leaky bucket is allowing one more extra request. So that we need to see in our logic, like how it is allowing one more request inside the limit. So for checking the coding part, you can go through the GitHub link for this repository and can go through the code link. I hope you like this video. Thanks for watching this.